Welcome back to our physics class. This is Raju, physics facilitator from our Tilford School. What we learned in our previous class, we learned about reflection of the light. What do you mean by reflection of the light? The bouncing back of light after striking the surface. And now we are going to learn about refraction of light. Do you have any idea about refraction of the light? Before knowing about this topic, let us recall our previous knowledge related to the light. Light seems to travel along straight line paths in a transparent medium. What do you mean by transparent medium? A medium which allows the light completely through it is called transparent medium. It's an optical medium. When you are in 7th class, you have performed some activities in your classroom, such as looking at candle through cardboards and looking at candle through pipeline. Now, when you come to this experiment, we looked at this candle through this straight line pipe. At the time, we were able to see the light of candle. And when we seen through this bent pipe, we were unable. These experiments concluded that light always travel in a straight line path. So that property, we call it as the rectilinear propagation of the light. Based on that property of the light, one device worked, that is pinhole camera. So here I have a question for you all. What happens when light enters from one transparent medium to another? We know one thing, light travels in a straight line paths in a transparent medium. But here question is different. What happens when light enters from one transparent medium to another? Does it still move along a straight line path or change its direction? Huh? Does it still move along a straight line path or change its direction? Let's see. Go ahead. Here on screen you can see the one picture, and this picture explain you about whether the light moves in a straight line path or it change direction when it travels from one transparent medium to another. Now here we are having the two transparent mediums. One is air medium and the second one is water medium. And these two mediums are separated by the boundary, or we can call interface. This line represents that it's the boundary or interface of air and water. In this case, light is entering from air medium. So that medium we can call incident medium. And light is entering to water medium. That medium we call refractive medium. So let's see. In this case, light is incidenting from air in the form of rays. Yes, here you can see light is entering. According to rectilinear propagation of the light, what it's supposed to be? It should move in a straight line path. Does it moving in a straight line path? Here you can see no. It's changing its direction. One more example, let us see. Here you can see one is the air transparent medium and second one is the glass, another transparent medium. In this case, light is entering from air to glass. This is what the incident ray, as we learned in our previous class. And when you draw a perpendicular line at point of incident is the normal, and angle between this incident ray and normal is the angle of incident. Here you can see on the screen angle of incident. Actually, according to rectilinear propagation of the light, what it's supposed to be? It's supposed to move in a straight path. This is what the actual path. Does it moving in the straight line path? No, it changed its direction. Here you can see red color light ray. Now, this is what? Normal. And what is this? Light ray. So the angle between this normal and this light ray, we call it as the angle of refraction. One is angle of incident. What is that? Angle between incident ray and normal. And second one is the angle of refraction. What is that? Angle between normal and this ray, we call it as the refractive ray. So we can say the angle between normal and refractive ray we call angle of refraction. Oh my god, these two words are new for us. So let us go through these two words. Let me define these two words. One is denser and second one is the rarer. Denser medium is nothing, just in given pair of media means plural form of mediums. In a given pair of media, which medium allows the light very fastly, that is the rarer medium. That is the rarer medium. In which medium the light speed up in a given pair of media is the rarer medium. In which medium the speed of the light is very less in a given pair of media is the denser medium. We can say denser medium means what? The medium which slow downs the light. Here on the screen we can see the two mediums. One is denser medium and the second one is the rarer medium. So we can give example. This denser medium we can take glass medium, glass, and this rarer medium is the air. Compared to glass and air, in air speed of the light is more, that is equal to 3 into 10 to the power 8 meter per second. When you see the glass medium, the speed of the light is 2 into 10 to the power 8 meter per second. In denser medium, speed of the light is less. In rarer medium, speed of the light is more. Here, light is entering from denser medium. Here you can see one red color light ray entering from denser medium to rarer medium. What happened? What happened? Already we learned when the light travels from one transparent medium to another, it changes its direction. Here you can see this green color one is the refractive ray. What happened? It changed its direction. Actually, according to rectilinear propagation of the light, what it's supposed to be? It's supposed to move in a straight line path. This is what? This is what the straight line path. But what happened? It moved in the different direction, changed its direction. And that direction also we can see based on the normal. Actually, this is what the normal. This is what the actual path of the incident light ray from the denser medium. What about this light ray? How it is moving? It is moving away from the normal. Away from the normal. So you can keep in your mind that when light rays enters from denser medium to rarer medium, they bend away from the normal. What is that? You can keep in your mind. Don't forget. It's very important statement. When light rays when light rays travel from denser medium to rarer medium, they bend away from the normal. They bend away from the normal. It is what the normal actual path of the incident light ray. It is moving away from the normal. Here we have one more example. In this case, what's happening? Light is entering from rarer medium to denser medium. The light ray is entering from rarer medium. Actual path of this light ray supposed to be this one. But what happened? Does it moving in the straight line path? No. It changed its direction. Green color light ray you can see. It changed. How that change is? Is that away from the normal? No. Actual path this one. This was the entered light ray. So how it is? It is coming near to the normal, or else you can say it bends towards normal. It bends towards normal. So you can keep in your mind one statement that rays when light rays travel from rarer to denser medium, they bend towards normal. They bend towards normal. Hello children, very very important statements these two are. One is when the light ray travel from denser to rarer, they bend away from the normal. Here you can see. And second one, when the light rays travel from rarer medium to denser medium, they bend towards normal. They bend towards normal. Here one more case. If you see in these two cases how the light is incidenting obliquely means with some angle, neither parallel nor perpendicular. That is what we call obliquely. But here if you see how the light is incidenting normally, that means perpendicularly. When the light is incidenting perpendicularly, does it change its direction? No, it won't change its directions. It travel in the straight line path. This is what the one case, very important. What is that? When the light travel from one medium to another medium, if the incidenting is normally, it won't change its direction. It moves in a straight line path. These three conditions very important. What is that? When the light travels from denser to rarer, they bend away from the normal. When the light travels from rarer to denser, they bend towards normal. At which condition? When the light rays are incidenting obliquely. Suppose when the light rays incident normally, what happen? It won't bend towards normal, away from the normal. It moves in a straight line path. If the light incidenting normally. We shall recall some of our day-to-day experiences. You might have observed that the bottom of the tank or a pond containing water appeared to be raised. You might have observed our school swimming pool. How it appears? It appears that the bottom of the swimming pool is rising when you are looking from outside. You might be noticed that. Here you can see one diagram on the screen. A boy is trying to find out the depth of the swimming pool, like you and me. When he is looking at swimming pool, actually the depth of the swimming pool is from here to here. This is what the depth of the swimming pool, real depth. But to this observer, a swimming pool depth appears to be till here. According to him, the depth of the swimming pool is this one, according to the observer. But actual depth, that is more than that. That is more than that, till here. But according to him, depth is this one. Actual depth, this one. So, for our clear understanding, we can use the ray diagram. Here you can see one more diagram. What is this? Air, a transparent medium. What is this? Water, a transparent medium. So now, in this case, observer is observing the depth of the swimming pool. So this is what the point he is observing from outside. From here, light rays will enter. One light ray is entering. One light ray is entering from water to air. That means you can say light rays are entering from denser medium to rare medium. When the light enter from denser medium to rare medium, what happens? The light rays bends away from the normal. Actually, when you see, this is what the normal. What is this? This light ray actual path is, should be this direction. But what happened? It bending away from the normal. From the same point, one more light ray. Same light is entering from water to air. It means denser to rare medium. It moves away from the normal. And when the observer sees these two light rays, they won't appear. But when he extend them backward, they meet at a one point. That will be the image of that point what the observer is observing. This is what the point in the swimming pool. But image of that point is here. To this observer, the point appears here. That means he thinks that the depth of the swimming pool only till here. But actually, is that the correct depth of the swimming pool? No. Actual depth is this one. This is what the apparent depth. This is what the apparent depth. Similarly, when a thick glass slab is placed over some printed matter, the letters appear raised when viewed through the glass slab. You might be using your glass slab or glass plate placing on a printed matter, or else placing on your book. Sometimes when you see the letters through the glass slab or glass plate, how they appear? They appear to be raised. You might be having that experience. Here you can see on this diagram, these are the letters on the paper. F, H, C, P, Z. But when you see through this glass, how they are appearing? They are appearing very big and they are appearing to be raised. Why does it happen? Why? Why swimming pool depth is appearing to be raised? Why letters under the glass slab appearing to be raised? Why? That is what my question. It might be striking you somewhere. Have you seen a pencil partly immersed in a water in a glass tumbler? Have you? Have you seen a pencil partly immersed in a water in a glass tumbler? Have you seen? Oh my God, you can see here on the screen a pencil partly immersed in a glass of tumbler. Glass tumbler. In this glass tumbler, what is there? Water is there. How the pencil is there appearing? It is appearing to be bent. For your clear understanding, this is what the eye of you, eye of an observer. This is what the tip of your pencil. From here, light rays will enter. This is what the incident ray from the water body. This is what the water, and this is what the air medium. When the light is traveling from water to air, what happens? Does it move in a straight line path? No, it bends away from the normal. Why? Because water is the denser medium, air is the rarer medium. When the light travels from denser medium to rare medium, the light rays bend away from the normal. From the same point, one more light ray from the denser medium to rare medium. What happened? They won't move in the straight line path. They move away from the normal. And when you extend them backward, they meet at a one point. That will be the image of that particular tip of the pencil. Actual tip position is here, but to the observer eye, it appears to be here. So it makes the observer eye to feel the pencil is bending in the water. How the pencil is appearing when partly immersed in a glass of water? It appears to be displaced or bent at the interface of air and water. This is what the interface of this what this is what the interface of air and water. Exactly here, what's happening? This pencil appeared to be displaced or appeared to be bent. You might have observed that a lemon kept in a water in a glass tumbler appeared to be bigger than its actual size. You may be having that experience. What is that? Place a lemon in a glass of water and see that from side above the water. How does it appear? Does it appear in a different way? Yes, it appears to be in a different way. How? It appears to be very bigger than its actual size. Here you can see. What is this? On screen you can see the diagram. This is what the your lemon outside. But when you place in glass of water, it appears to be very big. Very big. Why it's happening? Why? To know that, again we have to consider ray diagram. So this is what the point of your lemon. From here light ray enter. Since it is moving from water to air, same case, denser to rare, what happened? Will it move in the straight path? No, it moves away from the normal. When it moves away from the normal, this observer again extends backward and he see the image of that particular point here. This is what the point and image of that particular point he sees here, and it makes the person to feel a lemon is very bigger than its actual size. How can you account for such experiences? Alright, the bottom of the swimming pool appeared to be raised. A printed matter appeared to be raised when we seen through the glass slab. A lemon kept in glass of water appeared to be very bigger than its actual size. A pencil kept in a glass of water appeared to be bent or displaced at the interface of the air and water. How can you account for such experiences? How? Do you have any answer? Let us consider the case of the apparent displacement of a pencil partly immersed in a water. It might be making you to feel wonder why the pencil is appearing to be bent or displaced. Let us consider that case. Here you can see on the diagram, this was the pencil partly immersed in a glass of water. This is the tip of the pencil. From here light rays will enter. From here, this is the object. Light rays will enter. What is this medium? Water, a transparent medium. and this is the point of incident. Here the light incident ray striking. When you draw a perpendicular line to the boundary or the surface, that is the normal. Will it move in the straight path? No. Why it won't move in the straight path? Because medium has changed. So it moves away from the normal since it's moving to the rarer medium. It moves away from the normal. One light ray over from the tip of the pencil. Can you see the image? No. Image can be seen when the light rays are intersect actually or after extending them backward. Now from the same point you need one more light ray. This was the one more light ray. Same thing, light bend away from the normal. Do these light rays intersect at one point? No, but when you extend them backward, they meet at a one point. That is what the image of the your point from where the incident light rays are incidenting. So this is a virtual image of this particular tip of the pencil. Now this will be the image, and to this observer a pencil tip appear to be here, and like these images of that particular points, and when you see the pencil outside clearly you can see this makes pencil to be displaced at the interface of the water and air. So the light reaching you from the portion of the pencil inside the water, from the pencil inside the water, this is what the pencil inside the water, from here light reaching you, light rays reaching you seems to come from different direction. They seems to come from different direction compared to the part above the water. When you see this pencil now it became a two parts for us. One is a pencil above the water and pencil inside the water. From the inside the water you get some light rays and they seems to come from different direction than you are above the water. This makes the pencil appear to be displaced at the interface. For similar regions, the letters appear to be raised when seen through a glass placed over it. What is the reason? Just only one reason. The light rays seems to come from different directions when they are traveling from one transparent medium to another, such as air and water, water and air. For similar region, same thing. Why the letters appear to be raised? Because the light rays comes from the below the glass, seems to come from different directions than compared to the outside letters. And a lemon appeared to be bigger than its actual size. And a fish appeared to be different position. These were the actual fish, but when observer sees, he see the position of the fish in the different position. And a stick seems to bend or seems to be very short when he plays in the swimming pool or in a water body. Does a pencil appear to be displaced to the same extent if instead of water we use liquids like kerosene and turpentine? Kerosene and turpentine. Yeah, we have seen a pencil is appearing to be displaced when it is kept in the glass of water. But here my question, instead of water, we use liquids like kerosene or turpentine. Does it displace to the same extent? Will the letters appear to rise to the same height if we replace a glass slab with a transparent plastic slab? Yeah, we have seen letters appearing to be raised when we see through the glass slab. Instead of glass slab, if I use the plastic slab, do they appear to be raised? Yes, they appear to be raised. But here my question, do they appear to be raised to the same height what I seen through the glass slab? After performing those experiments, we can say you will find that after performing those experiments, the extent of the effect is different for the different pair of media. The pencil won't displace to the same extent if you use the liquids instead of water. Of course, they get displaced, but not to the same extent. These observations indicates that light does not travel in the same direction in all media. These observations, what kind of observation? What kind of observations? Hmm? What kind of observations? Yes. Lemon appeared to be big. Stick appeared to be very short in the water. Pencil appearing to be displaced at interface of air and water, or else bending of pencil. Rising of letters when we seen through the glass slab. So these kind of observations indicates that light does not travel in the same direction in all media. You know one thing, in all media, light won't travel with the same speed. The speed of the light is different for different medias. When you see the speed of light in vacuum, 3 into 10 to the power 8 meter per second. In air, 3 into 10 to the power 8 meter per second. Of course, it will be the less than that, but it's negligible. When you see the speed of the light in water, 2.25 into 10 to the power 8 meter per second. When you see in the glass, 2 into 10 to the power 8 meter per second. The speed of the light is different for different mediums. So that makes the light to travel or light to change its direction. Only the reason why the direction of the light is changing when it traveling from one medium to another. Only the reason because of different speeds in given pair of media. Different speeds in a given pair of media. So that makes the light to change its direction. It appears that when traveling obliquely from one medium to another, the direction of propagation of light, the second medium changes. So when we see the light, when it travels from one medium to another medium obliquely, I'm not talking about when the light is traveling normally. No, here the case is when the light is traveling from one medium to another medium obliquely, it means that with some angle or neither parallel nor perpendicular. When it travel, definitely in second medium, the direction of propagation of light changes. This phenomenon is known as refraction of the light. In simple words, we can say what is refraction of the light means the bending of light when it travels from one transparent medium to another. Once again I am repeating, what is refraction of the light means the bending of light when it travels from one transparent medium to another. Let us understand this phenomenon by further doing few activities So now we clear that light won't travel in the straight line path when it travels from one medium to another, because speed is different in different mediums. So that makes light to change its directions. So to understand that phenomenon, which phenomenon? Refraction of the light. Further, by doing few activities, let us perform some activities to understand what is refraction of the light. Activity 1. Place a coin at the bottom of the bucket filled with water. What do you have to do? Place the coin. Here you can see the two boys. One boy is trying to place the coin at the bottom of the bucket filled with water. With your eye to side above water, try to pick up the coin in one go. What you must do? Try to look at the coin from the side above the water. Not normally. From side above the water, try to pick up the coin in one go. In one go. Here you can see a girl is trying to pick up the coin in one go. Did you succeed in picking up the coin? Obviously, no. Repeat the activity. Why did you not succeed in doing it in one go? Why did you not succeed in doing it one go? Even though I too cannot. I also failed n number of times to pick up the coin in one go. Why? Because only simple reason. Actually, the position of the coin is here. But when the light rays travel from water to air, it bends away from the normal, and when I extend the light ray which is entering into my eye, it makes me to feel the coin is here. But is that actual position of the coin? No, it is only the image of that particular coin what I placed in the bucket of water. What I do, I will try to catch the image of the coin, but I cannot catch the original coin in one go. Ask your friend to do this. Compare your experience with theirs. Then activity 2, for understanding a phenomena, refraction of the light. Place a large shallow bowl on a table and put a coin in it. Take a bowl, here you can see, take a one bowl and place a coin in that, or put one coin in that. Next, move away slowly from the bowl. You must move slowly from the bowl. Stop when the coin just disappears from your sight. Ask your friend to pour water gently into the bowl without disturbing the coin. What you must do? You should ask your friend to pour water gently into the bowl without disturbing the coin. Keep looking for the coin from your position. Does the coin becomes visible again from your position? Yes. Obviously you can see the coin. Before you was unable to see the coin. The coin was disappeared. But now you can see the position of the coin, or that coin is visible to you. How could this happen? How could this happen? Can you think of it? Yes, the coin becomes visible again on pouring water into the bowl. The coin appears slightly raised above its actual position due to refraction of the light. What happened? When your friend pouring water in the bowl of water, when your friend pouring water in the bowl, the coin appears to slightly raised from its actual position. Actually, the coin is not rising, but it appears to rise from its position. It's due to the refraction of the light. Let's recap. Over. Our session is over. So what we learned in our in this class, bending of light when it travels from one medium to another is called refraction of the light. That's what we learned in this class. Effects of reflection, refraction, effects of refractions. One is pool of water appears less deep than it's actually. Already we gone through those kind of examples. A pool of water appears to be less deep than its actual size. We cannot see the actual deep or actual depth of the swimming pool or the water bodies. It's just because of refraction of the light. If a lemon is kept in a glass of water, it appears to be bigger when viewed from side of a glass. That also one kind of experience what we are having every day and in our day-to-day life. Lemon, when you see normally, you can see the actual size of the lemon. But same lemon, if you keep in a glass of water, it appears to be very bigger than its actual size. It's because of refraction of light. An object appears to be raised when it is placed under water. You can see already we did an experiment or activity. We placed a coin in the water. What happened? A coin appears to be raised. Not only coin, even though when you place one stick in the water bodies, the stick appeared to be raised. So this is because of refraction of the light. A pencil appeared to be bent when it is partly immersed in a glass of water. It's because of refraction of the light. Letters appear to be raised when seen through the glass slab placed over it. It's because of refraction of the light. So, we learned only two things. First, what is the refraction of the light? Second, what are the effects of refraction of the light? What is refraction of the light? The bending of light when it travels from one medium to another. You know one thing? Stars appears to be twinkle just because of refraction of the light. So many natural phenomena are there. What makes our nature to be beautiful? So many, n number of effects of refraction of the light. I hope you all understood. Have a great day. Thank you. Till 4. Have a great day.